my presentation, the title, soil compaction, the hidden damage. And that's very deliberately because it's a very important aspect of the way we address it or the way we do not address it. Because to me, compaction as a threat to soil is subsoil compaction. I'm aware that compaction of top layers may have importance, for instance, for triggering water erosion, for instance, by animals compacting the topsoil. But in my perception, this should be addressed as a part of the soil water erosion issue. So I'm speaking about subsoil compaction. It is a hidden damage. And I also speak about, and I'll show you that it's a permanent damage. And due to this, I have, first of all, I tried to follow the idea of the organizers. I should not be too specific, so I use some general terms and come around some soil compaction things. So I'll speak about resilience because there's this issue of persistence. And then I'll speak about some drivers and the need for regulation. And then something about risk assessment. I think it's only been mentioned once in these 2 days, risk areas. I think it was the person presenting work package 8 mentioning the high risk areas. And risk assessment is actually very important for how we explicitly use our funding, we use our forces. And then a few things about the soil compaction, just a few things. Resilience. In general terms, in the general ecosystem terms, you can have form of the soil, it can be a function, or it can be a structural form. And then you can speak about its stability. It can be resistant to some external impact. And that's one thing, it's important to know about that. In compaction, then the strength, if it's higher than the stress, it's resistant to that compaction. But resilience means, well, it can return to its original state. And that's what I'm trying to show you shortly, that that is a problem for subsoil compaction. It's a very low resilient damage. Yes, and then about resilience, I'll give you an example. That in Denmark, 50 years ago, we had an intensive, like in many countries, intensive nitrogen fertilization in Danish agriculture. And everything was a bloom of green algae along in watersheds and in the near coast sea. And we had problems with fish dying in the ocean and so on. And then we had regulations, and what was the regulation included that slurry application should only take place in the spring, because there was no regulation before that, and the slurry simply run nearly directly to the streams. And actually nowadays people can, there's very fresh water in the harbor of Copenhagen. So the resilience with this damage, which is another damage, it's not soils, it's a total ecosystem. It's about 25 years. It's clean waters now. We've solved the problem. But we have induced or added to the soil compaction problem. Because as I said, one way of regulating was that we banned the farmers to go with their slurry in the autumn because it would be leaching in the winter. So then they start, from 1st of February they are allowed to go with their very heavy equipment, and it's very effective, it's very heavy equipment, and it's spring wet or winter wet soil. So nowadays, I'll return to these two cores, showing some soil pores, reference and compacted. But now we have a situation that we are inducing damage from this compaction that is perhaps persistent simply, at least very low resilient. Before I return to these two cores, I'll show you a measurement I did some years ago. One of these lines is penetration resistance, very empirical measurement, the mechanical rod you push into the soil to 60 centimeter here. And this has been measured in the garden of an estate where there's not been any traffic. And so what you could see here is probably the natural density or resistance of a native, what we call the inherent soil. But the other The other curve is showing if we measure in the field around this estate. So that's how it is, and this has been replicated several locations, also in Sweden, for instance, at a lot of occasions. That this is how it looks. We have in mechanized agriculture has infused a densification, especially in that area just below the plant bed. But my anticipation is that this will go deeper because now we're using heavier machinery. So just to show that we have the problem and we need to take care it's not going further down. Then a few words about these cores again. They were sampled 30 years after one traffic event in a heavy clay soil in Finland. And this one is from 30 to 40 centimeter depth. And this is one is the control one, and the other one was trafficked with, at that time, heavy equipment, about 5 tons of wheel load, which is only half or less than half what we use today. But still, 30 years after, we came and sampled, and we found, this is CT scanning, and we found a reduction. And a few words about impacts, putting this in now. Well, we could say, okay, that's how it should look, but maybe it works anyway. But if we make a conceptual model of the pores, and we were able to do that, because we used some gas transport properties to characterize the pore system. So we have a pore system in this subsoil, and that's generally for subsoil, that can be simulated by the human blood system. We have arterial pores, marginal pores, and also some remote or block pores. And to make it simple, to make the story short, this is what has happened. The marginal pores has nearly disappeared. You see, there's just a single one left. I mean, this is just a sketch, but they have disappeared. The volume of the sponge-like remote pores has nearly reduced to nothing. And the arterial pores is much more narrow. And this has certain impacts. Probably we may expect reduced aeration of the bulk soil. It may also have a root penetration in that part of the soil. And that small pore will easily trigger preferential flow, because if you have a near saturated condition, suddenly you have a saturated condition. So you have preferential flow with potentially taking pollutants to deeper layers. So certainly, as you understand, I think we need to do something about this. And what has to be done? Drivers and response. Decades ago, it was like that the farmer had a sense of soil. I'm not claiming at all that we should go back to that kind of farming, but the conscience of the farmer, he has a near contact to the soil, and the farmer should deliver the soil to his son as he received it from his father. That was something inherited. Nowadays, at least in Denmark, and I think pretty many Western European countries, it has turned out to be very, very, very big farms with directors sitting in their offices, having contractors going to the field with very effective and very heavy machinery. So when I go to speak to farmers, sometimes they say, okay, what will it cost if we go with this machinery? Well, in average, perhaps up to 5%. It may be higher, by the way, with the wheel load we have today. But even if we say 10%, I think maybe this director, not farmer, but director would say, okay, I can live with that. But sustainability, and now it's actually a personal opinion of me as a citizen, not as a researcher. Sustainability should be just from more than short-term economic viability. And that's why when we speak about the DPSR concept, that we have a situation where economy is the driver. And we know that it's not an issue, it's not a solution to go over there where we have the state and the impact and try to mechanically subsoil the soil, because there's been many studies showing that that will only create more problems. So in my mind, again, this is policy, that we need to make regulation, because the economy is there. It's the market. So that's at least my opinion on this. Okay, risk assessment. When we are going to address this more specifically, we need to know very explicitly what we are speaking about. And risk assessment was defined by the OECD some years ago. And this is a process intended to calculate or estimate the risk to a given target organism. In this case, it's our soil, including the identification of attendant uncertainties following exposure to a particular agent. So something is coming and pressing this particular system. And this should take place with focus on the agent of concern as well as the characteristics of the specific target system. Sorry for this heavy text, but I think it's very important to acknowledge this is the soil and this is what disturbs it. And now I'm perhaps provoking. I think I've heard a lot of words of indicators of soil, but we need to explicitly, in my opinion, to include quantitative estimates of what is disturbing. For instance, in work package 2, I think we should include more specifically what are actually affecting the soil, not just the soil parameters. And I have a bit provoking way of illustrating this, because if we just look down here and measure and monitor, and I think, is this a risk situation where you would say probably, if you look up there, you would say probably. Luckily, we are in a situation that we have created models, so we're able to predict from measurement actually the stress distribution on the wheels. And we are also able to predict from the characteristics of the tire dimension how the stress input to the soil will be. So, in my terms, the disturbing agent is now quantified. We know it. We can do that across all wheels we know. We have a problem with the belts here. We need a model for that as well. But we're actually able to quantitatively describe the disturbing agent. Okay, then we are also able to predict what stresses go down into the soil. I can see I haven't time to go in much detail here, but it's some measurements in the field where I will point to the fact that we had 4 different combinations, the big wheel and the small wheel, and the different inflation pressures. And then at 2 different loads, wheel loads. And what you can see is that those combinations with the same wheel load goes to the same level of stress in the depth. So this is telling us that independent of the wheel, the tire, the stresses in the depth is determined by the load of the machinery. And this is really the big challenge. Really the big challenge. We need to do something not to have too high stresses down here. Yes. And finally, this is actually now I'm there where I speak about the soil system. What is the soil able to resist the stresses? Now I'm speaking about, I'm characterizing the system, because this is showing the soil strength, the soil mechanical strength as affected by clay content and water content. These are some new data from a lot of laboratory measurements, which shows that we are able to predict the strength of the soil. So we have the disturbing agent and we have the strength of the system. So we're able actually to test whether we have a sustainable condition if we will have compaction. So I'll conclude or summarize that, in my opinion, it's important to focus most of our power to poor resilient soil degradation. And in modern agriculture, that's a personal view. Driver is economy, and the function need to be a regulation. It can also be put in a way, I think, in one of the papers I tried to read about the VOCAT tool. It was stated something like, you can have killer scores, something like that. If you have a situation where you have really a situation that you know you're doing a damage that is persistent, it's a killer score, isn't it, the term you're using? So by this I'm saying we may have a problem with our stakeholder negotiation if we know that we're doing permanent damage. And then the risk assessment focus both and mechanistically based decision support rather than rigid rules. And after I had written this, I realized that this is a new world for me, the way you're working with RECARE and these different options of choosing sustainable systems. To me, it's important as much as possible to use the knowledge we have when we select the sustainable measures we can use. Yeah, and with more research, I'll jump these two. Thank you for your attention.
Thank you.